1, 2, 4, 8, 16. Why? How? Possible. I really cannot think of a reason. Why that would happen. Okay, let me make some small ASCII art here. Excuse me. The idea is that we have a prime number. Let's say 5. And then after that, all integers that are not divisible by smaller primes. So not divisible by 3 and not divisible by 2, because those are the two primes that are smaller than 5. Which means 7, 11, 13, 17. What's 15 is divisible by 3. 19, 23, 25. And so on. Also note that this just simply means that we add 2 here, and now we add 4, and now we add 2 again, and now we add 4 again, and then we add 2 again, and then we add 4 again, and then we add 2 again, and so on. So really, we only need this 2 and this 4, and then it starts to repeat. I want it, however, to return the primes. Let's say where do I have my subscripts? Some other file. Subscripts. We have some subscripts. P1 is this one. Begin is 3, so that is P3. I think that in the case of begin is 3, and is going to be mm, 11, right? And that's P5. I don't have P5. Jesus. What are we doing here? Okay, well, primes is primes, previous is previous if, begin, now we talked about it, that was this. That's the 3 here. And then I have an end, which is 5. And then we have n, which starts at begin. To hell with the underscores in my note, in my comments. I don't know current yet. Right. It's a super short example. But it's either almost nothing or very much. I could do the next one, but it's already 8 numbers instead of 2. So let's try to work with this one. I wanted to return 5 and then 7 and then 11, etc. Right? And it repeats after 2. So it has 2 gaps, but 3 prime numbers. So one more than the number of gaps. I think I need a 5 as well. I could begin with setting. I think I have to do something like if begin and end lay far apart, and this is usually false. So the fast path is just this line, and then, well, return it. So in that case, I don't update current. I just read an array and add that to current, and that will return that. Don't have to update current. And that was my goal. Otherwise, it gets twice as slow, basically, if I want to update current as well. And it should be possible, because if we just set current to 0 in the beginning, and I just return a prime, then I return this one here, right? So if n is 3, and n is equal to begin the first time, so that is p3 is 5. I mean n is 3 and primes p3 is 5. And then if current is 0, then next becomes 5. It's just equal to that prime, which we then return. So the first call, I return basically p3, which is 5. And I increment n. So the next time I call it, we return p4, which is 7. And then n is incremented again, so now n becomes 5, which happens to be equal to end. So then we do some magic. And then the next time we call it, I want to return 11. Yeah. But n is going to be reset to begin. So this is 5 again. So current must be set to 6. And I'll just keep that in the object, I think, as opposed to recalculating it every time. Primorial is a function which is the number of, so just 2 times 3 times 5 times 7 times 11, etc. until the prime number that you pass. I'm going to pass a prime index, I think. And we need it to be 6, so 2 times 3. So I need to pass the index of prime 3, which is the one before P3, so we need to pass begin -1. And then I have to define primorial. Which takes begin, prime index, and excuse me. Yeah, that has to that needs prime numbers, so I have to make it a member function of primes, I guess. So this is then prime n times the primorial of n-1. And of course, if n is small enough, less than something, then it is just 1. What is it if n is less than what? Looks like if it is less than 1 even. AKA if it is 0. It is an int, but well, I'll do less. Yeah, so this would work if P, I don't think I'm ever calling it for n is 0 though. Or actually I do, because I subtract 1. What is my first begin value? The lowest, I think I started with the lowest one. The lowest begin value is 1, I think. Yeah, definitely it's what I'm starting with, so I might as well, then I pass 0, but not less than 0. But okay, 0 is possible. That would be less than 1, so then where's my primorial? Here. Now you have to ask for subscript 0. Hardly readable, might as well use a real colon. See how that looks like. I think I like that better. Right, so then note that if begin is 3, and we call primorial 2, which means 2 is not less than 1, so we do p2, which is 3, times the primorial of 1, so that's just going to be 6 in total. So this is primorial is going to be set to 6, which then means that we add 6 to current. The current was set to 0, so then we get 6 plus 5 is 11. And then the next time we get 6 plus 7, which is 13. And now we add the primorial again, so now current becomes 12. And I don't think current is the right word anymore, so I have to think of something else. What is a better word for current? It's more like a base or something, a base. Or the, yeah, well, anything but current. Let's call it a base for now. Substitute current is a base. No declaration matches. I have to add my primorial to the primes. Yeah. No, put there. Totally cons, isn't it? All that trouble for printing all the integers. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's perfect. So now I'm going to do we think. I think I should make this the default constructor. Oh, I don't have a default constructor. I need to pass primes at the very least. So begin was the prime 2, which is P1. No, I just have it here below. I think 1 and 2, right? Yeah. 1 and 2. So end is 2. And then n is begin, then is also 1. Base starts at 0. Primorial, yeah, well, it's just 6. Expected value is 0. And then here I'm not going to pass primes, I think. I just pass a sieve. And I get primes from the previous sieve. Meer oeuvre. If I have the previous sieve, I also know what the begin is actually. Or, well, I think so. I think it's just always one more. So that would be the previous sieve begin plus 1. In the end is it's a new function. Does that function have a name? I don't know. Let me ask. Oh, ChatGPT won't know that, I think. Let's see. Primorial. I want to use that. What was it now? The online. The online indice encyclopedia. No, it's not. I forgot it again. I think online. IO. Yeah, IO. Oh, it is iOS. So I need some. I want something like 3, which is I think. No, wait a minute. 1. 1 times 3 minus 1, so that's 2. Times 5 minus 1, it's 8. Times 7 minus 1, it's times 6, that would be 48. Times 11 minus 1, times 13 minus 1. The local minima of the order is 5 function. What the hell that may be? Doesn't really have a name apparently. It's a phi of the product of the first n-prime in primes. Huh? This was the formula that I used. It doesn't have a special name. Okay, I'm gonna call it repeat, because that's what it is in the end. It's my own function. So end is going to be begin plus repeat, I think. Yeah. Begin plus repeat. The repeat of something. And I want to have a prime index. Oh, wait a minute. It's not that easy. Or is it? Plus 8. Oh, it is an index. Yeah. Begin is an index, and then the repeat has to be added to the prime index, and then we get another prime index. So what I looked at was, I did look at the repeat values, yeah, but okay, begin. Repeat begin, begin plus repeat begin. If I'm not mistaken, let's define repeat. So, well, the type is an offset of a prime index type, but I might as well use prime index type, I guess. Of repeat. That definitely takes a prime index. Let's call that n again. And I do need the primes again, so it is again something, a member of primes. And this returns basically I think this It's the most. Yeah, product is a capital Pi, but it's probably not that much better to read than just the LaTeX formula that we have now. But yeah, I work with p index something for prime, so let's use that then. So I need p, yes, I need subscript k. Subscript k, bitch. Now he's ignoring me. Oh, certainly. Certainly. Okay, -1. No, I'm happy with that. Did we already have a subscript 4? Yes, I did. Yeah. Okay, 3, 5, 4. This is 2 minus 1 is 1, 2, 3, 5, 7. Yeah, let's test it. So if n is 2, then we must take the product of k is 1 and 2. That's not 1, it's 2. Huh? Wait a minute. Back to the drawing board. I was using here repeat begin, and then I had calculated, let's use this one, which was 5. Let's begin is 3. So repeat 3 is 2. No, less than 3. It must be 1. Can't help it. Is this correct? Let's test it out. Of course, I don't know. And I've called that one, of course. So this gives me repeat 4 is 8. And I'm not sure I'm happy with that. Repeat 2 is 1, that is correct actually. Repeat 3 must be 2. Wait, this is an index, not the prime number. So the 4 here stands for 1, 2, 3, 4, which repeats after 8 times. That is correct. 2, 3. This looks to be correct. So now we have our end. And as again, begin in the beginning. Don't have begin anymore though. Begin then. Because this is base starts always at 0. Primorial, that was already a formula. Also defined at of base and expected failure, we have that as at 0 at the moment. Although actually it must be 0 here, but it's not 0 here. No, it's not. Let's keep it at 0 for now. Otherwise we are screwed. And this then I think works as well. So let's make a Sieve array. Is that even possible? No. You're a bit far-fetched. Create another Sieve. Constructed from S2. Well. Does my Sieve accept a reference? Maybe I should even make this a reference. No, it's a null pointer. Must be a pointer. Although let's pass a reference here. And go from reference to pointer. No, that blew up. That blew up faster than you could say blew up. That is, this looks perfectly fine. But this blew up. Why? It worked before. I don't think it changed anything. Yeah, it's so weird. I have no clue whatsoever why this suddenly stopped working. This before this printed 2, 3, 4, 5, 6, 7, and so on. The next one must print everything that all the integers starting at 3 that are not divisible by. Well, actually, all integers larger than 1 that are not divisible by 2, which is all odd integers larger than 1, and that is indeed 3, 5, 7, 9, 11, and so on. Perfect. So this works, and that one suddenly broke for no reason at all. Really weird. GDB, break main, run, next, Sieve 2, no care. That's correct. We don't have a previous Sieve. The begin is the first prime, and is the second prime. The begin at the beginning. The base is 0, and you don't have an expected failure. Next. Print next. That is doing the following. You have not expected failure, of course. Integer next is base plus primes pn. So base is 0. Painstakingly you print everything out. Pretty sure that this is 2. So next becomes 2. That is indeed the first thing that we have to print out. N is 1, and that becomes now equal to end, I think, yes. So we immediately add the the primorial was probably wrong. No, that was 6. That was correct. Well, we added a bit quick. Oh, end is wrong. Or is it? Wait a minute. What's going on here? Two and 3. I think this primorial is wrong, but I have no idea why it worked before, and now suddenly no longer. I did something with primorial 6, but that was for a totally different prime, right? I don't know. Anyway, we set n to begin again, which is 2. So we keep printing 2, and the next one must be 3, so primorial should have been 1. Why is it 6? Because I set it to 6. No, I thought it should have been 1. It should be 1, actually. That's better. And I'm not printing the primorial. Fix that mistake. Base and expected value. Primorial in the middle. Printing Sieve. Okay, so these are all the integers starting at 2. These are all integers starting at 3 that are not divisible by any prime below 3, aka 2, aka all the odd numbers. And then we go to the next one until we are satisfied that the thing works. Yeah, I also have the feeling that this should be possible to do this in a loop. But oh, we couldn't because you don't have enough primes, I think. Yeah, Let's fix that first then. Already running out of primes. Oh yeah, actually I get it, I think. 19, 23, 29, 31, 37, 41. Okay. I don't want to make a mistake. 41, 43, 47, 53, 59, 61, 67, 71, 29. I don't know more. You never know when you need it. 23. Put them there as well. What? No. Too many initializers, seriously. So how many do I have here? Did this work? The all integers starting at 3, all odd integers starting at starting at 2, and this one started start at 5, and then we get all integers that not divisible by 2 or 3, so they are all odd. 6 is missing, 9 is missing, 27 is missing. Looks good. Facts, I have them listed here. 5, 7, 11, 13, 17, 19, 23, 25, that's the only ones that are listed. While laying in bed. Yes, I should be sleeping when laying in bed, but... And then the next one is 7, yeah, all the way up till, and then we skip 25, and we skip 35, and 49 is still there, and we skip 55, so it looks good. This looks good. But we terribly cheated. We cheated because I filled in all the primes in advance, which is of course not what we should do. Suppose I don't know any prime at all. Then things would go wrong at the very, very, very first number. because we're going to try to add a 0 plus 2, and we don't, 2 is a prime number, which we don't have. So that's going to assert. Like immediately. N is 1, Pn is 2. We don't know that 2 is a prime. Oh, that happens there. Yeah, that's not, sorry, that's not acceptable. I want to be able to print this anyhow. DBP. N is still 1, of course. In this case, we try to get that from here, from Sieve next. And we can't do that because expected failure is 0. We cannot enter here. So I have to set expected failure to something, but there is no failure. Because this is just the very, very first thing. This is Sieve, oops, up, S2. That's the first thing we even created. So yeah, I don't have to deal with that. So I'm going to add 2 as the first prime. And I think we still crash in S2 now. So no S2, but S3. Oh. Oh yeah, just giving 2 is already enough to have everything. How is that possible? How is that possible? Oh, that's because it adds primorial. Yeah. So what we do is we return 2, and then we increment base with primorial, and then we return base plus 2. So it is continuously base plus 2. So we only use the first prime. So we don't need prime number 3. By coincidence, I would almost say or think. N is 2. Well, that would be the prime number 3. Yeah, so we cannot return 3. Okay. I think we're going to use an algorithm. So I'm setting an expected failure. Therefore, we're going to use an algorithm. And while using that algorithm, the first failure is going to be 4. Why is it going to be 4? Because I think it's just simply the square of the previous prime. So we can now initialize. Expected failure. So the default constructor, I set it to 0 because we already added the prime number 2. And therefore we don't have to calculate that from mysterious previous sieves that don't sieve anything. And here I'm going to add the square of the previous prime. How do we do that? Where do we get my primes from here? Primes. No. I'm just going to ask primes, I think. We do everywhere. Square. So the square of the prime begin minus 1. Pn to the power 2, here's a power 2. Suddenly not sure anymore if I want to end my comments with a dot. Existential crisis, I tell you. Okay, so now we're going to assert, after fixing that stupid thing that is for the 3rd time wrong. Keep forgetting to add the member function definitions or whatever. Declarations, I meant. This is just assert false, yeah, because now we have an expected failure of 4. Ta-da, it is 4. So I have to now implement this part here. How does that work? Okay, well, that's very easy actually. What I'm going to do is ask the previous sieve for the next number. It's never easy, is it? I think it has to be in a so-called reset state, and that means the bloody sieve is an iterator in itself. And I don't want to make a copy of it. Or I could make a copy of it, but yeah, no, it should be internal actually. So the whole thing that I'm doing here in main is bullshit. I want to have no sieves whatsoever at all. I could put the first sieve into. Oh, this is going to be complex again. No. I think. Okay, we are printing stuff here, which messes up, which just messes the thing up, which is not, well, I don't want that. So I put all that around it. Now we know what it generates. And then we start fresh, okay? Does it make any sense? This thing should probably also work with a copy of primes then. Because it might mess that one up. So we're gonna work with a copy of primes. And then we do the actual thing. Here, let me think. Yeah, I should use the copy of primes again, so we should use this S2. So there's no doing that. We just can only do that. And then the rest is nonsense for now. So we start with the fresh S2 and the fresh primes. So I don't even need to make a copy then, this is a default constructed thing. So we start fresh here, and here I want to print the stuff anyway. So we make a spare primes. Right, so now the previous sieve is at least fresh. And then we call next on S3. So if now call next on S2, which we have passed in, we get 2. And I want to get 3. So we have to call next once, as in printing and that would be our first prime. Yes, so if you now call next again on S2, I get 3. And then if I call next again, I get 4, and so on. I guess that's what I want. And then I can make this work by calling, well, next on the previous one. we're doing next is previous. Previous Sieve. Next. Now remember that the previous sieve is simply the one that generates all integers that are not divisible by any prime below the previous prime. So the only thing we now have to check for to do the right thing is to test if it is divisible by our prime. Yeah, so this is the correct answer, as in I'm just going to use the previous next. And then it was silent. Yeah. One of the things I want is to have my own prime handy. Let's add it. Well, I can just read it every time from here, or shall I make a cache copy here? I need it a lot, so maybe I should make a copy here. Cache. Hmm. It starts with 4. That's not good. It should start with 3. I'm calling next an extra time now, right? So we begin with next. And then the first time we enter next, we'll call it again. That's no good. Should not do this. Let's see. Yeah. It's a bit of a hack, but okay. Let's try it to abuse base. And then we do, you don't call next, we just turn the prime number. So now it starts at 3. And then 4 is the first failure, so we should detect that. I also want to store the prime here, because I know that it's a prime. Syntax. Thanks. Thank you for the nice compliment. Islands. Expected failure. Now we have to go to the next expected failure. And that's where I was really very afraid of, because that means that I need a second iterator. And I maneuvered my inversion 6 again in a position where I don't have a second iterator. Why did I even think that I didn't need one? Really, really, really? Let's postpone it. I'm gonna set it to 6. Almost works. So these are all integers. And these are all odd integers, as you can see. 3, 5, 7, oops, 8. The reason that I didn't see that 8 is not an odd integer is because I didn't set expected failure to 8. However, It should already work, because this thing has a primorial of 2, so we are done after the 5. I don't even need a 6 here, actually. So what I can do is set the expected failure to 0, because 5 minus 3 is already equal to primorial. Or do I have to wait for the 7? Let's leave in the middle if it's what the reason is. I just set it to 0 and then see if we are setting it to 0 too soon. So really I would have to do something like if something set it to 0. Oh, what? That's a disappointment. How the hell is that possible? 3, 5, 4. It's going down. Oh, I have to do the first base. Let me think. Why am I ending up here all the time? Next. I want to end up like here. Line 152. I think I need to add another primorial here because we ran into an expected failure. So let's say I have another next, and then we also have this. I'm just guessing here, it's horrible. Really, really bad. I think N is still base, right? Well, it worked. All integers, all odd integers. So apparently it's enough that we have the 5 at that point. We do have the 5, right? Yeah, next becomes 5 here. So I'm going to do something like if next minus base, no, wait a minute. Next minus prime equals primorial. I thought primorial was 1. Nah. Primorial is 2. Try this. Yep, that works. Great. So what I'm doing now is, if expected failure is set, that means that we do not have everything already calculated. And if base is 0, that means that we just started. So that's just the very first thing. I set base to primorial here because it's then non-zero, okay? And we store that first prime and we return the first prime. And the next time then we skip this as well. And then I get the next number from the previous sieve, which is omits, well, doesn't skip all the numbers that are divisible by prime itself. But we anticipate that by testing if it is. As long as it's not divisible by prime, then it's also not divisible by any primes before that prime, because we get it from the previous sieve. So that is the correct next value then. And if it is an expected failure, then we have to skip it. We always only have to skip one. So I just call next again, and then I'm sure that this is not the case. And now we can return that, but we still have to set expected failure to a new number. Also, base must be shifted because not sure about this one. I think this is not true, actually. I think this is only true once we do this. So ignoring this test here, so let's say this doesn't happen, then we just skip one. It's equal to expected value. Therefore, we get the next value exactly like this line here. We do that again. So we just skip that next, and we get the next one, and then we return that. So we just skip the one. But then, of course, if this never happens, then we do need a new expected value. And then the next expected value is equal to prime times, yeah, well, another next. So I need another previous sieve, which is very annoying-ish. Except for one thing, this one goes slower than that one. So theoretically, I should already have it, as in there is not going to happen an expected failure. So maybe I should call another next, which is simpler, which assumes that we just can do this. So that is a second n. It's just a second n, isn't it? Oh no, and a base, a second base. I think so. So let's call next gap. I'm going to rename that, and then this one is next vector or something. Next offset. It's a vector round. Prime times something. It's a vector. I'm calling next vector on the previous sieve. Now let's keep next being next. And then we have to implement that. So it's going to look a lot like this one. Except that it's called next vector. And it is assuming that it doesn't need to do an expected failure. So we can just do that. But with another n and another base. I'm going to call this vector base and vector n. Vector n, vector base, vector n. And then we need to add those. Base. And we need to have to initialize them. Beats me. I don't think I even need them here. Or do I? Yes, of course I do. So this is going to be something that when called should return. Let me think. I don't know. Let's treat them the same at the moment. The line is getting too long. I'm going to put everything on its own line. Chi base at vector base. So I'm going to gamble that can be 0 and the other one vector n here underscore 1. Oops, no, yeah, whatever. Let's copy 1. No idea if we even tested that new code now. Did we? We'll have to print them anyway. Vector n below n. Yeah, I think we never even tested, so. But if I comment this out for now, then that should still work, except it's slightly slower then. And now we can see what it does, if it works. So this prime here is now 3, right? And expected failure was 4, must become 6. No, that's weird. It was 2, sorry. Prime must be 2, I think. Huh? Oh, it must be the previous bloody prime. Ugh, fuck. Darshan Rai, don't become depressed, man. It's mostly obsession, doing the whole day, nothing else, your whole life long. I don't. Well, whatever. And I don't think this shows much talent, does it? Does it? I mean, I'm good with VI because I haven't generated any primes yet. Not for a whole week. It's pretty bad. This must be the current prime, which is just primes begin. How do I get that? It should exist by now. It should exist. I have stored it here, so it exists. And we have a primes apparently. No, this is store. Fuck. What is primes here? Okay, I have a primes. I'm just assuming that we have a primes here. Primes.p something, and that is on the begin. Class Sieve has no member named primes. You mean primes? I don't get it. I thought this was compiling before. How did I suddenly lose my primes? Here it is, isn't it? Yeah, that's the one that I want to call. Sieve primes. Mm-hmm. Now, if anyone sees it, the first error is class Sieve has no member named primes. Oh, right, it doesn't have nothing. It doesn't have begin. It doesn't have anything. Our expression cannot be used as a function. It's completely... It has become completely mad. But it doesn't tell me where the error is. It has no member print on. So it does have the member, but it can't find any members anymore. What did I do wrong? parenthesis is missing here. Yep. It's not working. So expected value was not updated to anything that we encountered afterwards. 11, 12, 13, that's just all integers. I expect it to be set to 4 again then maybe. I suppose we have to debug this in the debugger. What was it? List 152. Let's just do a break at 148. No, that is an S2. I want to look at S3. So really we want to do break. Let's see, 217. There's a, oops, there's a 1. Continue. And level 1. Continue. So now we're calling next on S3. S3 is currently at the beginning. And S2 and begin is 2. Expected failure is 4. Okay, so that was the one that we're going to find first. So we call next on the previous sieve, and that should return I think 3. It didn't print anything yet. Oh. What happened? Oh, we have a breakpoint. It's breaking inside this function here now. Okay, so now expected failure is 0. Yep. So that's going to return, what did I say? 3, right? Yep. So now next is 3. And base is 0 because this is the first time. So we enter here. And then we set base to something else. And I store the 3 as the next prime. So now primes is 2, 3, 1, 2, 3. And we return that. So I do continue, we print the next one. And now we're going to get 4 here. Yeah, guess I'll just do, no, I don't know. It's gonna break again. Continue. Next. So this thing is going to return 4. And then now base is set, so continue here. And now 4 equals expected value. And now we are finally where I wanted to test the code. So we call next because we want to skip this one. And then next becomes 5, which is what you want, skipping 4. So we do again continue and then get out of here. And that then is 5. And then we skipped so much that we don't see the code anymore. That was this one. So next is set to 5 now. And now finally the line that we wanted to see. Expected failure is something, and we want, last failure was 4, so now the next expected failure is 6. And the previous prime must be 2, because I am here pointing at my paper. It is 2. Yeah, so I want previous Sieve to return 3. What it's going to return 2. Pretty sure about that. So instead of having set to 4 directly, did I set 4 directly? Where did I set my expected failure? I should have set the I set the expected failure to prime squared, but it would have been better to set it to previous prime times this thing. And then we already called the next vector, and then this would work. I'm just doing next, I think. And now expected failure is 4 again. Yeah. So let's search for expected failure initialization, and we should do that by calling next vector directly. So actually it's previous prime times next vector, as in that one. However, is this thing, is that already working at this point? Because that's only really working if we call at least next on previous Sieve once before. And I'm not sure I did. Oh, actually, I think I did, right? Yes, I did. So here in main. Let's do next. So even before passing it to S3, next has already been called. I think that should work then, hopefully. Well, looks good. Looks good. So all integers and all integers not divisible by 2, all odd integers. Now, that means that this line is now correct, I think. So if I do that again, it still works, of course. But now we can test the next one. So let's test S4. So I print the next prime by calling next on S3. Sieve S4 S3. Let's print that. And then let's print that. Oh. Trying to get a prime that we didn't generate yet. Which one? Does this look sane? We did generate 2 primes, and the 3 here is indeed added. Begin is 3. So this the next thing has as begin 5, the prime 5, index 3. The previous prime is 3, yes. The end is 11 because we're going to go from 5 to 11. Is that correct? Let me look at my paper. That looks fine. Yep. N is 3, just equal to begin. Factor N is also 3 because it was that's strange. Oh wait, no, we call expected value was calculated by calling next factor, but that was on the previous one. So this one is still at the beginning. Base is 0, factor base is 0, primorial 6, that's also correct, and expected next value should be a prime squared, previous prime squared. Yeah, because the last time it was 4, so now it's 9. Yeah, it looks completely correctly initialized anyways, and then we are trying to do what? Trying to get prime 4, which is 7, and we don't have 7 yet. Hell, we don't even have 5, I think. Why would I try to get 4? Why would I get get 7 here? You've not expected failure. How did that get set to 0 then? Where are we? Expected failure is 0, yep. That's nonsense. Didn't generate all the way up till 11 yet. A second ago it was 9. So it got set to 0 like for no reason whatsoever. And there's 4. Primorial is 6. Okay, I think that so that test is wrong. The test is wrong. This test is wrong because it set expected failure to 0. Last time, when I commented this out, it worked. That doesn't say that much, maybe. No, I'll try it anyway. Yeah, that does work, right? So these are all integers not divisible by 2 and not divisible by 3. So the 9 is gone, 15 is gone. It's plus 2, plus 4, plus 2, plus 4, plus 2, plus 4, plus 2, plus 4, plus 2. Yep, perfect. So then what the hell is wrong with that test here? I want to have a breakpoint here if... Actually, I want to have a breakpoint when this goes wrong at the beginning of the function. Or does it... Nah, it doesn't even matter. It doesn't do anything. Well, actually it does. Next is being called here. I want to have a breakpoint here. And I have no idea. Because I'm stupid. I guess I'm getting tired. Knew I forgot something. Count is 5. I have no idea where this comes from. Oh, it's... Oh, okay. Yeah. Doesn't that mean that 7 should already be in there? Let's see, 11 minus 5 is 6. That's what I want to test. So we reach 11. Anyway, breakpoint count is 5 seems to be a good plan. Break 164 condition 1 count equals, what was it, 5? Run. So at this point, the current sieve is, the begin is the third prime, which is 2, 5, 7? 7? No, wait a minute. I'm skipping 3. 2, 3, 5. Yeah, 5, and then previous prime is therefore 3, and is 5, and is 5. That's wrong. It should be 11. Oh, what's... It's an index. The 5th prime. Oh, looks good then, right? The 5th prime is, as if I know that from my head, 5th prime is 11, yeah. And n is 3. Still at the beginning. Factors at the beginning. Base is 6 already. Okay. Why is base 6 already? No. Nobody gets it. Factor base is 0. Whatever. Probably that's correct. Expected fill is 9. That's also correct. The last one was 7. So I think that now we are going to get the 9. I can do next. Print next is 9. Yep. Oh yeah, I was wondering why base was 6, but it's just because base is not used yet. So base is unequal 0. Very nice. Should I not set base back then at some point? It's already primorial. For when? Okay, next. If next is fill, yes. Next becomes, now we skip something. So if now I do next, I get, obviously, 9 plus 2 is 11. Yeah. And then it says, well, that's kind of what I expected. So 11 minus the base prime, which is 5, is, that is 6, yeah. We're done. Provided the 11 is pushed. Did we already push it? No, of course we didn't push it. Oh, yeah, okay, I'm getting it. Okay. I'm adding primes at the wrong moment. So I do have 11 now and I can push that to primes, but I'm not. So what we do here is just set expected failure to 0 without pushing the 11. That feels completely wrong. Completely wrong. Bases are already set to primorial. I think you can remove that. Yeah, I should remove that line. Huh? Yeah. Okay. And now we crash. Okay, so the problem is still simply that we're not pushing 11 at the right moment. Guess I'll keep this one. Keep this for now. At the moment I'm storing primes here, but I should be storing all the primes here as well. And then I think we're getting duplicates at some point. So I have to check that as well then. Let's see how the duplicates exactly pop up. And this had to be removed. Yeah. Well, the count is getting in the way a little bit, but it's printing horrible stuff. I think it's printing 3, 5, 7, 11, 17, 23, 29. Is that even correct? Apart from the duplicates? No, it has to be bullshit. Let's just core dump on a store. Yeah, let's just core dump. If the store is not larger than the last one. Already a duplicate of 5. So I guess that this is the yeah, exactly. Now I get that from the previous one, which already stored it. So this line is always going to fail. Might as well remove it. Maybe then it works, or is that nonsensical? It's probably nonsensical, or maybe not. That's good. Let me think about that. This one stores. That doesn't store 2 then. I store was already stored. It does not store 2. This one stores 3, I think. 3 and 5. And then this stores 7 and 11. And then this one stores, I think, 11 again. So let's try removing this, and then I guess we get a duplicate of 11 instead of 5. It's at least an improvement to begin with. Doesn't look like I predicted. Oh, we're missing a prime now. Three wasn't stored, or not in time anyway. Yeah, that makes sense. Okay, that was not a good thing then. We need a different solution. Is there some smart way that I can know when this prime is new? Kind of confused though that I need to store it here. So now looks like an exception almost. We call next. It's a prime. It's probably this next also does that. That's why. Yeah, but then I would store it twice again. Huh? Okay, when is it a new prime? A new number. A new prime. I think it's a new prime exclusively when we get it from here. This means that expected value is null before calling next. Does this happen after an expected value? You think so? I would have to do it twice. Nero, it's no purpose, just a youth frustration. I described it in the first video about primes. Now, can I find that back? As in, I go to my YouTube. Hmm. Mm-hmm. I'm live. Playlist live. Prime. This one. And then it's a small font. Why is it a small font? Blow it up. And then when you get to 200, oh, there it is. So this is the reason. Well, maybe a bit exaggeration, but so my first program that I wrote on paper, because we didn't have a computer yet. I mean, that's a weird story, you think, but my father was working as a programmer, actually a system analyst, but okay, he also wrote programs, and he was doing a course on about programming from television, which was paid by his employer. Paid for by his employer. So he had books, and in the books were, what he had to learn to code, I guess. And then I looked in that book as well, of course. And at some point he decided to go buy a computer. So I had a book that explained how to code in GFA Basic. But he didn't buy the computer yet. And then I wrote a program just by writing it down on paper from the programming language that I learned from the book. That would calculate all primes up till 256. And it couldn't be larger because the bloody language didn't allow arrays larger than 256. And I invented... So later I was told, that's called the Sieve of Eratosthenes. So I felt annoyed because I never heard of the guy and I never used his work. It was my invention. And then someone else gets his name attached. And even worse, once we had a computer, there was also a computer club, and they made a tournament thing with a prize and stuff. People had to write a program that generated all primes till, I think, 1000 or something like that. So I reworked my program to have like 4 arrays. And I sent it in, and I didn't win because there was some adult who cheated by using peek and poke. It's just reading or writing to memory directly. And that way he emulated an array that was larger than 256. So, yeah, I felt kind of frustrated about that. I mean, like, cheated out of my first prize, as it were. So, ever since, I have been... yes, since I was 12, I've been trying to write... a program that is faster than the Sieve of Eratosthenes. And even if it is based on it, it's not based on this guy, because it was my invention as well, right? But I do need a new method. So now you know. So I have a new method that has, ties to the Eratosthenes method. And it definitely does. It's still not that I am standing on the shoulders of Eratosthenes with this, because I did it from scratch anyway. So I'm just being frustrated, I guess. I want to write a program that generates primes in a way that people say, "Wow, Carlo, nobody did it like that before. What good of you." They should have told me that when I was 12, I think. But, well. I never heard of the Sieve of Atkin. Don't tell me that what I'm doing now. Probably whatever I'm doing now is already been done. But, okay, and it's still fun. So that's what, maybe that's the main reason. Let's keep it at that. It's just fun. I like to do difficult stuff. Okay, in the meantime, I forgot what I was doing as usual. I thought as soon as I start talking to the chat. Oh, right, new prime. So I think that if the previous sieve is done, then whatever we generate is going to be a new prime. And we have to call that before calling next. Otherwise we won't know. And then this is dubious, to say the least. But apparently I don't need to check a new prime, and we can always store it here. Or maybe not. Maybe you'll run into it. And I think I have to do it again when calling next there. And then here we do if new prime store. Okay, now I have to implement the done on my sieve. Sieve, where's my sieve? This is the sieve. Primes, begin, looks like a nice place. Bool, done, const, return. Return not, oh fuck, not expected failure. Okay, well, that's exactly the same thing, but maybe just more logical somehow. Nope. Still duplicate. Okay. Well, then maybe, you know. There. So 5 is still stored twice. How? So this is the first time it's being stored, which is at the bottom of the 3 thing. So then it's done, isn't it? Then it is done. It is done. Huh? I don't get it. Call next. Previous Sieve next. And that returns 5. And then we call previous Sieve next, and that also returns 5. Probably a different previous Sieve, but still. That's not how I envisioned this. where n is what? N is the maximum integer or the number of primes? I'm hoping to be order n, where n is the number of primes. And since that is the log of the value, so then I'm gonna go, if your n is what I hope it is, then mine is going to be the O of log n. Seems doubtful, but well, should be fast. Yeah, that the n must be what I think it is, because Aristotle's I know, and that's order n log n, so... That must be the n must be the size of the array, right? So the largest integer that it is returning. Need a little bit more debug output to understand what's going on. And this count is super getting in the way. Oh, what the heck. I'm going to add, sorry guys, I'm going to add my debugging library again. Because I just miss it, and it's my library and I need it. I want it. And it's your lucky day, because that means that I have to put it on Git. Yeah, I wrote a debugging library that forces you to put your stuff on GitHub if you want to use it. How did I do that? It's amazing, isn't it? So, let's do that. Let me make this a little bit smaller so you can see everything. And when we go to repositories and make a new repository, find repository? No. New. There's no new. Looking. Create new. New repository. Okay. Pipes. Like Inglewood. No. Wait a minute. Let me switch to log out. Sign out. Sign out. Oh, nice. It's what the fuck is the thing doing in space? Sign in. Oh, I just have to do this, right? You just have to do this. Okay, there we are. And now, repositories. And we did. Oh, that's why I couldn't find new. New primes. Description. Fast prime generator. Create repository. Oh, I forgot to add a license. Oh no. And now? I think I have to clone it, empty and all. Or push an existing repository. Oh, could do that. I'm going to do remote add push u. So also a push to it. It's the same thing. I might as well do this then. Git init. Shall I add everything? Let's add everything. Let's git add. You get the whole shebang. 4, 5, and 6, and I don't want to add a makefile. Or should I? Nah. Primes 1, primes 2, quick test. Hello. There's a small readme, and a small readme too. No! I don't know what is in it. Well, the readme is important. Let's add those first. What is in the readme? Okay, as old stuff. I didn't even get that, I think. Oh, it's nice to have this list. Let's keep it. Readme 2. Set array. Nah, this is a bit amateuristic. When I was still a prime noob. Let's remove that one. Right. So git add readme then. Git status. Git commit. What is primes? Oh, I have to look at it. Primes. Just a lot of primes. Not that many. Git commit. Where's commit? Oh, it has to be lowercase and no dot. No, don't do that. And then we do git wait a minute. Can we still fix that? Primes. Let's just, I'm still on primes. I have to push this first. No. Issues. Settings. I found it. Pop up. Or maybe not. I did not find it. Code. They want you to push something. Okay. How about master? I don't do the main thing. Git remote add origin. Call it GitHub. And then it's Carlo GitHub or GitHub Carlo, I think. GitHub Carlo colon Carlo Wood / primes.git. Well, looks like the right thing to do, yes. And then I do git push -u GitHub master. That worked. And now I can reload this page. And then we can do readme that. What the fuck is readme doing here? Oh, does that? No, is that? Oh, that's the readme. Yeah. Okay. Well, that's good. Blah blah. Okay, what was I doing? I wanted to check my settings, and now finally we can see that master is the only branch. Oh, that wasn't too painful. Then we go back to repositories, because what I want is CWDS, which means that we have to use CWM4, which means I have to do this. And this. And get remote. Everything looks already fine. Git add. Commit. Git status. Git commit. And then we go to back to the thing that said that we need CWM4, but somehow we can't get here. Cloning, adding. As execute this in the root of the project, yes. And then lots of stuff that is not even true. Horrible. Well, this is true, but the whole build space stuff is wrong. Why am I not updating that? Okay, I have, thank God, only one file, so I'll have to add this to my one file. And this as well. And well to main. And then usually I add DRTC nodes entering main, so that I know that I have debug covered. And then it says finally run autogen. CMake, okay, that's not bad. Set grep CMake. Oh, apparently it does only support for CMake these days. Oh, it sees that there is no configure.ac, I think, but there is also no CMake list thing, so could create one for me. CMake lists.txt. Oh, and I have absolutely no idea what that should be. So we go here. Troop is changed. Projects. ICXX. Yeah, indeed. Let's use this should work. This should do the trick. How does this one look like, for example? Oh, I need a minimum. We need a minimum, whoops, control top, insert a minimum, but my version is currently CMake version, which means 3.27. I think it's gonna work just fine with 3.14. I hope. I have no idea. Just random. It looks like buy, so let's keep that. Okay, where are we? This is yeah. I was looking at this one. VI. We need to add a projects thing. This is called primes. This is I don't know. Fast small primes generator project. And of course we do everything in C++20 because yeah, I don't use anything from 20 yet, so let's set it at 70. Let's be nice to people. This is what I was looking for. I want to use libcwrd, of course, and that. And why not that? And that's also required, and we don't have subdirectories. Except that it doesn't work, so we have to copy just everything like that. And then let's go to source or something. Let's spy on how that works. CMake lists. Include. Yeah, I already have something included here. I'm not sure if I need this one now. Is that not the same thing then? Bit scared. Let's try to skip it. And then we add a thing, which is, for example, well, that one. CC. Oh my god. Let's rename it. Shall I call it CPP? No, I'm not doing that. So this is that one. Oh wait, I meant 6 of course. CXX. We're working on 6. Good. Now, I don't know. Now I need my build environment, as in environment, yes. Infinite source. There's already something in it. This is never easy. Let's see what I have here. PE. Yeah, I should move it to projects as well. Let me have that one already. That would be nice. Because now it's a thing, you know, as in. Can you just move that like primes to projects? And then still have git work. So now I have projects already. And yeah, this is probably also necessary, which is kind of annoying. Alias C, might as well add this. I like all these things. I have to admit. No, let's not do fix me. Maybe I want to do GDB. I want to do everything. It's kind of stupid. I'm just going to source it. Source, I forgot the directory name, of course. Oh, could have done that. Okay. Bloop, bloop, bloop. I'll be nice and call this home. And then we have, really, this one. Do I already have a top project or not? Firestorm, so basically no I don't. Let's set that in primes as well. I need to set top project. That is then this. And default configuration options. That looks like auto tools. So I just need this one. CMake only. Copy. Turn that below here. Voice to my on, why not? Enable. I'm not even sure if I need it. Let's keep it in. Enable debug on. No, whatever. Aliases. Yeah, we don't have utils. Does this thing build in an object here? Why would it do that? That would be make, I think. So try what we have now. Which make? Definitely have a make. Which configure? Okay, let me just try it. Cannot create primes object there. Yeah, so it does try that. Okay, make there. C++. Oh, wait a minute. That's not what I wanted. I moved it to projects. Env.source. Oh yeah, that's nonsense. Projects. No configuration found for. We have to create this. Mcdir minus P VI let Copy that from here. That's probably right there. Do the same thing. Copy it. Oh. Configure. Make. This did build something or called fast primes. 6. Did I? No, I did not add that. So let's add that as well then. Can I just excuse me? I think something like this. No, my mouse is broken like hell. For source and base name, that is the source, but the thing resides there. To the object there, source. That should work. Source. Alias, does alias now exist? Yes, run it, codant. Entering main. So now I have debug output. Yeah. Almost feel like adding colors to it as well, to the output, but let's not do that. What was my problem? Oh yeah, I wanted to print when what is being called. I also have a make C text now, which is very nice, I think, except that it doesn't work. S is stuck on CWDS only. Right. Who defined that? Oh, right. And dot source. I need to add think like this. That added that. No. C text. Yay, colors. More colors. So now I can jump to stuff. Right, and I wanted to print if whenever next is being entered. So I will do dout entering DC notice. This is in Sieve, I guess. Sieve. Next. Normally I print this pointer, but I probably should just print start here. No. Begin. Can't type. I still don't like the indexes. Let's just print primes debug p begin. I'm just going to print that instead, actually. Yeah, there's a lot of returning 5 going on, which is probably normal. So let's see what exactly is happening. So at the moment we try to get the word next is a bit weird here, but the Sieve with the base prime 5 means that something that returns all integers that are not divisible by any prime less than 5. So the first number is going to be 5. Because everything below it is, of course, except for 1, divisible by a prime below 5. But it doesn't know 5 yet, so instead it asks the thing below it, which is a prime. So it asks for any number that is not divisible by 2. And even that it doesn't know, so it asks for just any number. And that one is at 4 apparently, so that returns 4. I mean, it has already returned 2 and 3 then, so now it returns 4. And then it says that this one was checking if, for stuff that is divisible by 4, by 2. So it says, whoopsie, that's divisible by 2, skipping. And then we're calling next, and then we get, the next number, which is not 4, but 5. So now 5 is being returned by that Sieve. At that point, that Sieve is finished with the repeat, so it's fully initialized. And it returns the 5 to the Sieve above that. And then this one, that is, no, this is printed by, entering does an indentation. So anything at this level is inside this function. So the initial run is being printed by this function, which means by the thing that has a 5. And yes, of course, 5 is the first number, like I explained in the beginning. So initial run just means that it got a 5 while it itself is named 5. And I didn't print any debug output regarding when it is storing primes. Let's add that so we can see the white is here crashing, which means that it stores 5 twice. I can add it in store itself, I guess. So it does it here before returning it, right? So that would be this one. You got to wonder why this one didn't store it. I mean, the 5 is new, even here. I guess this one doesn't store anything because it's number 2. That thing just generates all integers, so if that would store anything, it would just store everything. Anything, everything. Or, well, yeah, it doesn't store anything. We give it the 2 for free, so it doesn't have to store the 2. afterwards expected value is 0, and then it doesn't store anything. So that's just really the main reason that it doesn't store it. So this one is still generating its internal state. Now it's done, but this one is still part of its internal state generation, and therefore it's a new prime. It is a new prime, so yeah, that's why it's storing it. And then what I would want is that we don't store it again. So why does that go wrong? This one, even though it's the initial run, so it's its own prime, it's not storing it because it knows that this one did store it. But then apparently we forget about that. Entering Sieve next 5. That. Did we already return here or not? I think so. This is annoying, this 5 here. What's the 5 doing there? Yeah, I'm writing stuff to standard CR. I should not do that anymore. Lots and stuff. Is that all? Yep. Let's make let's write this to, yeah, what I notice. Also notice, it's like the real output. Or just add a new line everywhere. That should work. Would work. Yeah, okay, let's do that. Not even needed that the print is. I mean, we already have it printed. Just calling S2 next is good enough. Output, whatever. Okay, this is S4. This is ridiculous. Let's not do that at all anymore. Make good. What the hell is that? S4 arrow, and then yeah, that doesn't work. VI. That's my loop. Okay, now at least it doesn't screw up my indentation. So it returns 5 and then we print it. And that's all, everything is from S4. S4 starts at 5, so it's simply the first output. Oh, really? Seems kind of strange though. Printing a 2 here without an arrow, then what is that? Oh, that's the other ones. Well, okay, so 2, 3, 5. Yeah, I'm getting it. Well, let's change that anyway. The same thing, yeah, same thing. I should do auto next is S2 next, and then print it. Returning 2, returning 3. Okay. Now, why is it trying to store this 5? So 3 is finished, aka has this set to 0. And here we're inside 3. Expected fill is 0. That's being returned. It's impossible that it stores that. How is this possible? Yes, not impossible. It's like literally, because it is done, it stores it. What No, don't really get it, but let's try something. So now if we call next on the previous sieve, and that next is returned literally, and we don't touch stored in the meantime. For example here, then that next is returned. And if stored was set, then it's still set. It only gets set to true. But it wasn't stored, and we store it and we set stored to true. Yeah, this is called, but we store is false. And then that next is returned as is. Therefore we do this stuff here. So that should work, except that I have an initial call to next, which doesn't pass a boolean yet. Here's one. Stuff in main. Only stuff in main. Interesting. So stored is set whenever we print that it is stored. That's clear enough then. And here, yeah, I guess I need a stored boolean that I can pass. But we don't want to do that, so instead just call next. Let's see. I don't care if it is stored here. I could no, I don't care if it's stored. Well, actually, it's in. Yeah, well, if it's stored as a prime and otherwise not, I guess. That would be interesting to know. Maybe. No, it's not interesting. So I'm going to add a next without a boolean. And nothing changed. What? Entering Sieve next false. Yeah, okay. Okay. I think we made a new mathematical discovery. Addition is not commutative. 3 plus 2 is unequal 2 plus 3. That's why it tries to store it again. Yeah. Pretty amazing stuff. Now, what I could do, of course, is add code that just checks that it was already stored and then not store it. But that sounds like a horrible waste, because why generate 5 at all when we already have it? I would much rather, not be bothered with generating 5 again. So why am I doing that at all? This is calling next on 5. while we already have that. Okay. Yeah, so what it might do, I think, is detect that. Might detect that is a certain prime to a certain point already exist, and therefore just return them. What is expected failure at that point? I think expected failure is here 9, which is larger than 7. Is that not a maybe an indication here? Hmm. Oh, wait a minute. Wait a minute. I think I'm asking the wrong. I'm having the wrong demands for these objects. In the end, theoretically, I should be calling them all the way up till. See, I can generate 5 and 7 here. And then go to that one. Then I want to get 11 back. I can go all the way up till 37. And then go to that one. Yes. Yes. So if I do that for now in main, I have to keep calling next on the sieve until it returns the prime just before the square of the previous prime. And then go to the next sieve, and that's the way that they should be treated. So let's treat them in the let's treat them in the right way by doing the following. So the prime that belongs to S2 is 2, I think. Yeah, that's why I called it 2. and it returns 2. Let me see. What is my bloody square here? The previous one. It's actually 1 squared. It exists as well. Yeah, this is a special case. I think we're done with that one. So then we go to S3, which definitely can be called until 4 squared. Oh, oops. Is that true? No. There should be 9, so it's its own square, right? So the previous one can be called for 1 more then. 2. So this one, let me just hard code it in as in prime type last, whatever. So this must be the prime before 2 squared, so that's 3. And then next returns an integer. Try do. I think we have to call it at least once. Yeah, to put it outside the do while, otherwise it doesn't know what next is at that point. And here I just call them call it continuously, but I should not call next on something before I called it, at least until the square, up till the square of the previous prime. So this should be the right way to treat it, and then it will still go wrong, but at least then I can fix it in the correct way. Let me think. Is this correct? I think so. Just try that. That bloody doesn't crash. But S3 is returning 4. Everything is being returned now. So it returns all integers. That's not what we wanted. Okay, I said it was going wrong. I not expected it to go wrong like this. So yeah, so I call next on, I don't think I need a boolean anymore, right? No, because I don't want to need a boolean because it just sounds inefficient, right? So get rid of that stored boolean. Get rid of this. Yeah. Oh, stored. Reference, yeah, okay. What? Stored. I see myself added back at some point, but for now, we'll try it like this. Stored is false. Just call next. If we do it efficiently, then whatever we calculate here should be new prime, and therefore it should be stored. Duh. No, at least now we crash again. We're due to a double store. But it already goes wrong here. Okay, so what I do is we call on number 2 next twice, which gives us the 2 and the 3. Then I call next on 3, and that should start with returning 5. And the reason it doesn't is because it is initialized wrong now. So if we initialize it correctly, it should know that this one went all the way up till 3, and therefore it is expected to begin at 5. And then the rest is even more nonsense, right? Right. Initialization of this one. It's gonna be a tough one. I'm afraid I need some more ASCII art now. It's not that much anymore as it used to be. But I just have to, I'll just, type in what I have on my paper here. And the idea is as follows. I have a sieve, let's call them sieve 2, which returns all integers. So it returns 2, 3, 4, 5, and so on. And I put in here the offset. So you see what the offset is between each thing. And as you see, the offset repeats. So it's kind of completely unnecessary to go beyond this point. The 3 is pretty fine to be the last one, because after that it repeats. Okay, next one. If we just return 3 is the first number, which I do at the moment, and I'll just put it here because then it's lined up with the other one. Then this one should return all odd integers, right? So next one is then 5, 7, 9, 11, 13, and so on. And then as you can see, there is also here, there's just +2. +2 also repeats. So actually we didn't have to do this at all. repeats already. Yeah, and then we get 5. So that should return all numbers that are not divisible by 2 and also not by 3. Which means it should return 7, 11, 13, 17, 19, 23, and so on. And that means that this is an offset of +2, and this is an offset of +4, and after that it repeats. So actually you don't need these either. Okay, I need to do more, I'm afraid. Seven. So this one returns all integers that are not divisible by whatever this one is not divisible by. Also not by 5. Yeah, so the 5 is not here because 5 is divisible by 5. And as you can see, the 4, that this one generates everything. The 4 is not here because the 4 is divisible by 2, and 6 is not here because it is divisible by 2, and 9 is not here because it is divisible by 3. That's what I should say, of course. So 9. Not the first thing that is not in this list but is in this list is the square of that one. So the first one that is not in this list that is in this list is the square of that one, is 25. So we have to go a whole way for the 25 to drop out, and then we get 11, so that would be +4, and this is just the same as this list, so I can repeat the +2 and the +4, +2, +4, and then we get +2, so the 25 would be generated by this one, or is generated by this one rather. But this one skips it, because it says, hey, 25 is divisible by 5. So it's not in this list. So here we get, it skips it, so we had +2, and then we do +4 again, and we get 29. So that becomes +6 here. So I see it clearly not repeating. And then we get +2 to get to 31. And then we get +4 to get 35, but that's again divisible by 5, so we skip it. And then we do again +4 to get, sorry, +2 to get 37. So we have a +2 and a +4, so again +6, and then we get 37. And then it repeats. So now we can go at the top and just add +4 to get 41 and so on. So this is the whole column. However, all the way up till the square of 25, this column is the same as that column. Therefore, there is no need to go to the second column. And that's my last change. So the square of 2 is 4, so we generate 2 and 3 here. And then the square of 3 is 9, so we use this one to generate. We just continue, even though it repeats, but we generate 7. Maybe we should remove this. So now you see that we only did the 2 repeats, but we generate the 7 as well. We do not generate a 9 because that's equal to the square. Just like the 4 here was not actually generated. It's requested by this one. But we don't need this column here to do the 2 and the 3. And then we go to this column, which then asks for the 4. And then says, yeah, but 4 is now visible by 2, so I skip it. So it creates a 5. And then it's done because it knows it's done. So it just adds 2 to that to get 7. And then it stops because it doesn't go till the 9, because that's the square of that. So then we create this one. And that then I want to start at 11. And that's the problem now. We must initialize this thing so it starts at 11. At that point, however, we can continue till 25, because this column and this column are going to be the same, hence these are all primes. So we can just do plus 2 to get 13, and then plus 4 to get 17, and then do plus 2 again to get 19, and then we do plus 4 again to get 23, and that's it. And I wasn't going to type these things because they are generated, but we already used the repeat. Like that. So now we want to start at the plus 11, which then, by the way, I'm not storing the gaps anymore. I'm only storing prime numbers. So all the gaps are gone. The only thing I store are prime numbers. So the plus 4 is just implied by the fact that it is 11 and 7 are 4 apart. So as soon as we have the prime numbers, we have the gaps, right? So it doesn't really matter if the plus 2 is mentioned here or there or wherever. I mean, this thing repeats, so this plus 2 is exactly the same thing as that plus 2. I'm just going to delete this because we don't need it. We want to continue at the 11. But I do need the plus 4 because that's the thing that's the difference between. I mean, it's not there. It's virtually there because it's a difference between 7 and 11. But I'm showing it anyway. So I think that then you have here the repeat is to 4, which kind of needs to be, yeah. It needs to be known that this thing really starts at where we had it, what we had before. So maybe I should add them. So this is the starting point, but I don't want to start generating there. So it's still, or we go back to, once we start wrapping, that is, the repeat comes after the 37, right? So the way I count, no, comes after the 49. Wait a minute, that's nonsense. No, nonsense. The repeat comes here already. After this is repeats. So we do 11, and then I calculate the 13 by repeating, meaning I do 11 plus 7 minus 5. So then we add the 2. And then the 17 is calculated by doing 13 plus 11 minus 7. That's how it works. Likewise, the 3 was already generated, so we don't need a 3. As output at least. And I have the 2 between brackets here because really it comes from there. But we use it in the end as the repeat. I'm using 5 and 7 and 5 for this column instead of 5 and 3. Okay, so this one generates all the way up till 25. And that means that these things are all initialized already because all those prime numbers are filled in. And that means that I have all these offset automatically. And that's the only thing I saw are prime numbers. So yeah, if I have the prime number, I have this whole column. It already exists. So what this thing should do is ask for the next number, which will be plus 4 plus 2 plus 4 plus 2 plus 4 plus 2, so 25. And then it sees that that is divisible by 5, so it skips it. And then I just ask for the next number, which is then plus 2 again, so then we get, no, we just did plus 2, so plus 4, and then we get 29. And then it pushes that onto the vector with prime numbers, and therefore the difference becomes automatically 6. And this thing continues until 7 squared. So the repeats start here, but we continue generating by repeating, which means after the 6 we get plus 4. So this is 41. And then plus 2, which is 43. Plus 4 again, 47. And that's the last one that we want to generate here. Because yeah, then we go over the 49. Let's do one more. So this one virtually starts at 11. Oops, one down. And then of course all the offsets are the same. So plus 2. Let me think. It's a lot of work. Nobody knows why. Well, actually, redo that then. Control V, Y, P. And then all of this must be applied. Because it was already generated. So it asks for the 49, and then it sees that it's divisible by 7, therefore it skips that, so it asks for the next number. And this thing then generates, well, God knows where that comes from. What is sum is 30, so I can just subtract 30 and then you can sit at 17. So we get 19 plus 30, 49, and then the next one is 23 plus 30, so it's 53. So that would be the next one which generated. And the offset between that is plus 6. Let's add these as well. This is plus 4. Plus 2. Plus 4. Yep. On this one I can go on till 11 squared. So yeah, that's too much. I'm not going to all the way down to 11 squared. Let's add one more. 59. Okay, I'll add more. And so on. So we need two things. We need to detect when to stop, which is just, yeah, when the next number is larger than the square. So maybe I should just generate it and then discard it. Maybe, well, it's going to be 9, right? Maybe I still need it, because this one would request a 9. I think we just continue until we see a 9, and then we say, oh, here's your 9. And then that's always going to be divisible by 3, so we might as well then get the next one. Why would it even pass the 9 then? Just throw it away. So I get the 9, create this object, and call next again, and then we get the 11. So how would that work in this case? Here we get the 25. We create this thing and immediately call that one, and it's always going to be a prime number. So it's 29. Yeah. So it's rather easy to get to 29 going, but then still, you know, the rest of the object has to be initialized. So how are we going to do that? And maybe it's time to put all of this into the primes object instead of in main. The interface of the primes object should just be that give me the next prime number. So let's create a thing with a single sieve, the first sieve, the default constructed sieve, as it were. Could put it on the heap. I did that before. It's not really necessary though, but it is necessary for the next one. So maybe need a pointer also to it at some point. Yeah, we need a pointer to it, right? We just keep calling next on the next sieve. So give prime pointer to the sieve, and then we call next on that. So where's my class? Class primes. I'll do a for declaration of sieve. And then we add here a sieve pointer to the current sieve. And then we initialize that with after the sieve is known. Sieve. Sieve. It's a pointer, right? So new sieve. This, I think, or this. No, I might as well pause this now, because just we have a pointer right there. Then we don't need all this shit anymore. Let's delete it. Yeah. Got to start small. No. Primes. All this debug output is kind of shitty, so let's do it like this. No, let's just use debug output. This is also dirty, but no, not as much. Primes dot next. Okay, so print all the bloody primes. Print the first 10 primes. I don't need to see this anymore. It just works. My sieve now takes a pointer instead of pointer, and then this is a pointer. Primes, it's a pointer. Primes is a pointer. Let's. Primes must return a pointer. Return a pointer. And I should be able to automate that. I'm actually so bad at VI. That's a different primes. It's not in sieves. This was a this. I think I did something wrong. Not sure, but we'll automatically get the complaint from the compiler. No, maybe not. Okay, so now my primes need a next. Did I already add that? Prime sieve. Primes p store next. Prime type next. Let's see, Sieve. Such much inline stuff. I do that, yeah. Primes the next. So what do you basically want is just we have a sieve, current sieve, which is a pointer, and then we call next on that. That's not going to work. Let's see if it still compiles. Primes is a pointer. Got one here. Primes is now returning a pointer. Oh, okay. Yeah, of course it did. It compiles, and now I want to see the horrible crash. Okay, the output looks really weird. A.out. Let's remove the thing before I make the same mistake again. Fast primes doesn't crash. Yeah, we keep calling next on the first sieve, which has very little to do with expected failure 0. It just returns all integers. So this is kind of expected, and we get just loads of outputs. Maybe make it a little bit more clear what I'm doing here. Printing here. Next prime. I did that in all caps before as well, so let's repeat that. Make and then run next prime. Okay, so first error at 4, and the reason is that we should never have gone to till 4 because we should be aware of the fact that the first thing might as well have an index for that, I think, because like a current sieve, the current prime sieve index. Prime index type, so just call it the current sieve. Which we then initialize as the first one is 2, right? So that would be the first prime 1. Oh. There. No, I need the next. We need the next. Primes next. Okay. So what we actually do is we have a new prime, a new candidate. Current sieve next. And we keep calling that until the candidate becomes equal to expected failure actually. I mean, it's the square of the thing, but that's not calculated square every time. Now I need to have an expected failure. It's better, maybe even. Well, I don't know. Current sieve. Make C tags vi. Jump to current sieve. Add an expected failure, which is an integer type, and which must be initialized as the square of this thing. It's 4. Make, and then we crash at returning 4. So it returns 4 here, and then we see that it is expected failure. What did we want to do at that point? We wanted to skip it. I think. It might not make much sense to call it again, although I'm sure that it is a prime, right? The next one, 5. Even though this one, now the 4 here, that is failing, the next one is always a prime, so we might as well return that. But we also have to prepare the next sieve at that point. And now we have to return something, but I don't know. I could create a new sieve and then call next on that. But the stupid thing is that the only way that it can do find this 5 is by asking that one. So no, we need a +2 here. We really need to. We need to do some. No. Sorry, the 2 is virtual. I just need to store the 5. It's the 4 was not stored, right? This thing doesn't store anything. So let's look at this one. If I call next on this one and it returns 9, then it did store the 9, I think. Whoa, we don't want that. So the sieve should not store anything anymore. No, prime should do that. Brilliant. Store. Don't store anything. And next, so I don't even need a store anymore. The moment we return something, now we know that it is a prime. I don't think the assertive is needed anymore. But well, let's keep it in for now. Maybe I want to write that we did that. But next thing I do is print that we have a new prime. So yeah, forget it. I think this looks good. Okay, so now we see the expected failure. We did not store it yet. What we need to do here is simply Sieve. Sorry, Sieve is new Sieve. But passing sieve. And then I just have to do this also, I guess. Primes destructor. That's always the case. Delete sieve. And then, yeah, recursively again. So the sieve thing itself. If you do delete null pointer, then it doesn't do anything. So you can just, again, just delete it without testing even. Right. So that cleans up the whole chain then, because that would be the last one in primes itself. That's the last sieve we created, and that has links till the first, all the way up till the first sieve. Hello, nice Agamon. If candidate, I was thinking, well, what am I forgetting? Now I realize what I'm forgetting. I didn't eat. Damn it. Yeah, I just have to eat. Sorry, guys. It's ridiculously late already. I put some chicken out of the fridge. Starts to. So it has been hours and hours at room temperature now. I hate to do this in the middle, but my programs are never finished, so really it doesn't really matter. But on the other hand, I feel I'm close, but I just have to eat. I'll be back in, I think, an hour or something like that. Okay. Yeah. Yeah, I have to eat. Have to eat it